Complex numbers is a very important topic in our advanced program mathematics, as well as in the A-level syllabus examined by the Cambridge. Basically, complex numbers allows us to be able to visualize numbers beyond the real number system. Let me give you just the motivation for complex numbers. For example, if you are given the equation x squared minus 9 equals to 0. No problem there with solving it. It therefore means that x squared is equals to 9. Then from there we put square roots both sides, which means x equals to plus or minus 3. Now let us also have a question whereby we have a question like x squared plus 9 equals to 0. Solving it therefore means x squared equals to minus 9. Then from there we put square roots both sides, therefore it will be x equals to, look at this point, we now need to make a square root of minus 9. Square root of minus 9, even our calculators would tell us that it's math error. So which means we must now be able to visualize the number system, the complex number system. Therefore, using the old method, it means x will be plus or minus square root of minus 9, but which cannot be even be visualized on the real number system. Therefore, going forward, it now means that what we now need to do is we now need to be able to extend our real number system to the complex number system. For example, if you are given, I'm going to give you I, which I'm going to call the imaginary part, if it's given as square root of minus 1. So which means here where there is minus 1, square root of minus 1, I'm going to replace it with I. Therefore, which in this case means that I'm saying my x will now be equals to plus or minus, instead of me putting minus 9 in the square root, I'm going to say plus or minus 3 square root of minus 1. Then square root of minus 1 is staying inside the square root. Why minus 1? Because it's coming from the square fact that this part of square root of minus 9, I can write it as square root of 9 multiplied by minus 1, which is equals to, taking it out, it will be 3 square root of minus 1. So that's where it's coming from. But because I have said square root of minus 1 is equals to I, it therefore means that x will be equals to plus or minus 3i. That becomes our solution to this equation when we extend our number system beyond the real number system, and we'll be looking at complex numbers. For example, quickly, if I give you x squared plus 4 equals to 0, it's a quadratic equation, which now implies that the x squared is equals to minus 4. We put square roots both sides, therefore x is equals to plus or minus square root of minus 4, which now means x is equals to plus or minus 2i, because it's a complex number. Thank you so much. God bless you. May you view my next video when we are doing the powers of complex numbers. Thank you so much.